In the early 1990s, Intel's x86 processors ran the vast majority of the world's personal computers, and challenging that dominance seemed almost pointless. Yet a small Silicon Valley startup called NexGen decided to try anyway, not by copying Intel's playbook, but by rethinking how an x86 chip should be built from the inside out. Its story would end not with victory over Intel, but with a quiet handoff that helped shape one of Intel's most serious rivals for years to come. This is the story of NexGen, a company most people have never heard of, and the chip design that outlived it. NexGen was founded in 1986 in Milpitas, California, at a time when Intel's x86 architecture was already becoming the backbone of the PC industry. By the early 1990s, companies like AMD and RISC were building x86-compatible chips of their own, mostly by reverse engineering or licensing Intel's designs and manufacturing close equivalents. NexGen chose a different path. Rather than build and operate its own semiconductor fabrication plants, an enormously expensive undertaking, it went fabless, designing chips in-house and contracting outside foundries, including IBM, to actually manufacture them. This let NexGen focus its limited capital on engineering talent and architecture rather than factories, a bet that it could outdesign Intel even without matching its manufacturing muscle. NexGen's first major product, the Nx586, arrived in 1994. Its core idea was unusual for the time. Instead of executing x86 instructions directly, the chip translated them internally into simpler RISC-like microoperations, then executed those with a fast, streamlined core. This decode and translate approach is now standard across the industry, but in the mid-1990s it was a genuine departure from how Intel's own Pentium worked. In raw integer performance, the Nx586 was competitive with, and in some benchmarks ahead of, Intel's Pentium chips at similar clock speeds. But it had real limitations. It lacked an integrated floating point unit, so tasks requiring heavy math needed a separate companion chip. And rather than using Socket 7, the connector standard that let Pentium-class chips share a common motherboard ecosystem, the Nx586 relied on its own proprietary bus, tying it to a small set of specially designed systems. Despite its architectural ingenuity, the Nx586 struggled commercially. Motherboard makers and PC builders were wary of committing to a proprietary platform when Socket 7 was becoming the industry's common ground, letting them mix and match processors from Intel, AMD, and RISC with ease. NexGen's chip required its own board designs, which meant fewer partners were willing to bet on it. NexGen also lacked the brand recognition and marketing weight of Intel, and even of AMD, making it a harder sell to cautious OEMs building systems for a public that largely equated a computer's speed with the word Pentium. Intel's scale advantage in manufacturing and its enormous marketing budget, epitomized by the Intel Inside campaign, made it extraordinarily difficult for a small challenger to gain real shelf space, however clever its engineering. Even as the Nx586 struggled in the market, NexGen's engineers were already working on its successor, an architecture that would fix the earlier chip's shortcomings with an integrated FPU and Socket 7 compatibility, aligning it with the mainstream PC ecosystem it had previously stood apart from. This next-generation design, sometimes referred to during development as the Nx686, was technically promising. But NexGen was running out of runway. Building competitive chips required continuous investment in design and fabrication contracts, and revenue from the Nx586 wasn't nearly enough to sustain that on its own. By 1995, NexGen was a company with a strong engineering roadmap but a fragile balance sheet, which made it an increasingly attractive target for a larger company looking to leap ahead in x86 design. In early 1996, AMD announced it would acquire NexGen, in a deal finalized that same year. AMD was, at the time, still leaning on licensed and reverse-engineered Intel designs for its own processors and needed a stronger, independently developed architecture to compete going forward. What AMD wanted most was not NexGen's factories, since NexGen didn't have its own fabs to begin with, but its engineering team and its in-progress next-generation design. Essentially, AMD was buying a roadmap and the people who could execute it, folding NexGen's Milpetis design team into its own operations and inheriting a project that was already well underway. That inherited design became the foundation of AMD's K6 processor, released in 1997. The K6 carried forward NexGen's decode to micro-ops philosophy while adding full Socket 7 compatibility and an integrated floating point unit, finally delivering on the promise NexGen's engineers had been chasing before the money ran out. The K6 proved to be a genuinely competitive chip against Intel's Pentium and early Pentium 2 processors, and it helped establish AMD for the first time as a lasting, credible rival to Intel rather than just a licensed alternative. NexGen itself never got to see that outcome under its own name, dissolved into AMD within months of the acquisition. But its core ideas didn't disappear. They shipped, sold, and competed, just wearing someone else's logo. NexGen set out to challenge Intel and never got the chance to do so directly, but the Underdog's blueprint outlived the company that drew it.